In this video, we're going to be doing the second scenario, which is a Earth and a satellite. And how do we calculate the gravitational force acting on an Earth and a satellite? Now, in the previous video, we have talked about body on a Earth's surface. The formula is going to be the same. Force equals to gravitational constant, big M, because the mass of Earth is represented as big M. The mass of the satellite will be a small m over, I'm just going to put a bracket here first, r, the radius of Earth. So the radius of Earth, and I'm going to close the bracket and just make it square like that, because I just need to explain one small thing when it comes to this formula, one small difference in this formula itself. Now notice that the satellite is not on the surface of the Earth, meaning that the radius reaches the surface and it doesn't reach the satellite. There is still a certain height towards it right here. Let me put a different color here. There is still a height here, and I'm going to put this as h. So the distance of the satellite to the center of the Earth is going to be r, the radius of the Earth, plus the height itself. So I'm going to put here plus h. And this is the full formula when we are calculating gravitational force between the Earth and a satellite. Everything else is the same. It's just that the distance is the radius plus the height of the satellite. Now let's add some values and figure out how we can use this formula with actual values. We know that the mass of the Earth, big M, equals to 5.98 times 10 to the power of 24. The satellite has a mass of 300 kg and it's hovering 200 kilometers above the Earth's surface. Now we have to find the gravitational force acting on the satellite from Earth. What we're going to do is we're going to plug in the values. We know that our force right here equals to big G. Big G will be 6.67 times 10 to the power of minus 11 times the big mass, which is the mass of the Earth, the big M, which will be 5.98 times 10 to the power of 24 times the mass of the satellite, which will be 300. And all this over the radius of the Earth, which is going to be 6.38 times 10 to the power of 6, plus the height, which will be 200. But remember one thing, when we are calculating force, the gravitational force, the unit we will be talking about for length will be meters, not kilometers. So we have to convert the kilometers to meters. And what we get? We know that 200 kilometers equals to 200 times 10 to the power of 3 meters right here. So we can know this as the height as well. So we go 200 times 10 to the power of 3. Close this bracket, make a bigger bracket, and square it. Now when we plug in all the values, you will get a gravitational force of 2763.74 Newton. So in summary, we know that the formula used is very similar to the formula used on body on Earth's surface. The only difference is that since the satellite is not on the surface but a certain height above the surface, we will count the radius plus the height squared as part of the formula right here. So in the next video, we're going to be doing Earth and Sun, and just a quick preview, the formula for Earth and Sun is going to be the exact same as body on Earth's surface. And I'll see you then.